3.8, solving system equations using inverse matrices. This is a big lesson. I'm going to show you how to solve a system equation using matrices, which makes it a lot faster than doing by hand or using Kramer's rule. First, we're going to talk about identity matrix. Now, if you remember what identity means, it's a number where in multiplication where you multiply by it, and you get the same number back. In regular multiplication, it's 1. In addition, when I add to something and get the same number back, it's 0. In matrices, when we're talking about identity matrix, we're talking about you multiply a matrix by it, and you're going to get the same matrix. And that's kind of hard because matrices are this row by column thing. You can only multiply certain matrices together. What's an identity matrix? It's this thing, 1, 0, 0, 1. That's an identity matrix. If you multiply by that matrix, you're going to get the exact same. And then same thing for 3 by 3. Or in general, n by n. When you do an identity matrix, all you do is do 1 as your diagonals and everything else 0. I was going to do a 4 by 4, look like this. Just have that one diagonal of 0s and everything else is 0. That's an identity matrix. You multiply by that thing and you get the exact same thing back. Let me show you. Let's do an example. Let's do 2, 3, negative 1, 4. Now we're going to multiply this by our identity matrix, 1, 0, 0, 1. The way we multiply, we'll put it up here. We'll draw a line where it's there's a space. And then what we do is you multiply the first 2. 2 times 1 is 2. Plus multiply the second 2, 0. Then I get to this one. I want to multiply this one, row 1 by column 1. Multiply the first 2, 0. And add the second 2, negative 1. It's all about rows by columns. Rows are the first, columns are the second. And then we have row 2. We're going to multiply that the first one, so 3 plus 0. And this last one here, this row by that column, is 0 plus 4. If you look at it, we get 4. Right? We get the exact same identity matrix. Now I can actually flip it. We could do it the other way because multiplying matrices is not cumulative. You get 2. Right here you get 1. Here you get 3. And right here 4. It doesn't matter. Either way, that's what this says right there. If you multiply a matrix by what we call the identity matrix, you get the same thing back. And it works the opposite way also. That's an identity. You multiply it, you get the exact same. In the matrices, that's 1, 0, 0, 1. Now, after we do identities, next thing we do is inverses. Inverse is how we solve things. If we have 3x equals 9, the way you solve this, you multiply by that inverse. Multiply by 3 by its inverse, which is 1/3 in multiplication. These cancel out because they're the identity, and you just get your answer. Multiplication identity is 1. That's why you get that. So an inverse does. Inverses cancel each other out and you get that identity back. How do we tell if two things are inverse of each other? When I multiply these two things, if these two things are inverse of each other, then when I multiply them, I should get the identity back, which is that 1, 0, 0, 1 thing. It's a quick way to tell if two matrices are inverse of each other. Just multiply them, and see if they cancel each other out, we get the identity. Multiply this together. Supposed to try both ways, but honestly, if it works one way, it's going to work the other way. Multiply the first 2, I get 1, plus multiply the second 2, I get 0. Over here, multiply the first 2, I get 1, plus multiply the second 2. Down here, multiply the first 2, 0, plus the second 2, 0. Right there, multiply the first 2, 0, plus the second 2, 1. If you add this up, I get 1. Those cancel, I get 0, 0, 1. Yeah, these are inverses. They cancel each other out when I multiply them. They're inverses. Let's try this one real quick. You probably could guess that this is not going to work. 2, 5, 1, 3. I multiply the first 2, I get 4. And then I multiply the second 2, I get 5. You got them up, I get 9. Right there, I can stop. I got 9. They're not inverses. Not inverses. I don't got to go any further. I got 9 on the first one. Definitely not 1, 0, 0, 1. That's a quick, easy way to tell if two things are inverse of each other. When you multiply them, they should cancel out. You get that identity back. So now we know what identity is in matrices. 1, 0, 0, 1. Right there. We know how to tell if two things are inverse of each other. So they cancel each other out. The next thing is, how do I find an inverse by itself? If I just want an inverse of a matrix, how do I find it? Well, with that, formula for it. And it's right here. General idea is, if I give you A, which is this, let's say A, B, C, D. And if I want the inverse, A to the negative 1 power, what we do is 1 over the determinant of A, which is that right there, but we call that determinant. Then right here, it's a little funky. What you do is you switch these two, and then you change the sign on these two. If they're negative, they become positive. They're positive, negative. And that's the formula. I will provide you the formula. You just gotta know how to use the formula, so you have that. Let's go here. Let's do this example. Let's find the inverse of this thing. First thing I have to do, you don't have to write it down, but in your head, you want to know what A, B, and C is. Step 1, if you want to find the inverse, it's 1 over the determinant. So remember the way we do determinant? We go down minus 6 times 0 minus negative 3 times. You get 0 minus 3, or just negative 3. And this is the determinant first. Down minus up. Next part, we're going to switch these two. It becomes a 0, and that becomes a 6. Then we change the signs on these two. That negative 3 becomes a positive 3. That negative 1 becomes a positive 1. And that's my inverse. But we're not done there. Distribute that thing. And we're going to multiply by that scalar. 0, negative 1/3 times 3 is negative 1. Negative 1/3 times 1 is negative 1/3. And negative 1/3 times 6 is negative 2. There is my inverse. Now let's check and see if it actually works. If they're inverses of each other, when I multiply them, I should get the identity. Negative 1, 0, 0, negative 1. I'm going to do a quick check just to show you, just to prove to you that they are. All right, draw a line here. Multiply the first, I get 0 plus negative 3 times negative 1/3 is just 1. Negative 3 times negative 2 is positive 6. Here I get 0 plus 0. Then here I get 1 plus 0. Look at that. 1, 0, 0, 1. So they are inverses. This method does work. That's the way you find inverses. Let's do another one. Let's do this one real quick, actually. We'll do these two. I'll try and make it quick. Right here, I'm going to do the formula, which is 1 over the determinant of A inverse. And then this formula here is switch these two and negate these two. Okay, let's do this. A, B, C, D. First, the inverse, the determinant, I should say. Down minus up, I get 1 over 12. That's 2 times 0 minus 4 times 3. Oh, 1 over negative 12, sorry. Then right here, I'm going to switch these two, 0, 2. And I'm going to change the sign on those two. That's 4 and 3. So distribute, and I get 0. 4 times 12 is 4 over 12, which is negative 1/3. 3 times that to be negative 1/4. And 2 over 12 is 1/6. One of the reasons I did that, I want to show you doing the calculator. It's actually very easy to do. Calculator, turn it on. Go to second calculator. We're going to type in our 2x2 matrix, the starting one. Make the 2x2 this time. 2, 4, negative 3, and 0. All we're going to do is this. We're going to select our matrix, the one we just did. Now we want to hit the inverse button. Inverse. Well, that's actually the same button as the matrix button, just without the second one right there. Hit enter, and there's our answer. There's the inverse. But I don't use long decimals. What we're going to do is make that a fraction. Very simple. Just go to math. You see how the first one says arrow fraction? What that does is it makes sure answer into a fraction. It can't be turned into a fraction. There we go. 0, negative 1/4, 1/3, negative 1/6. Same thing I got right there. One more of these inverse ones, and then we'll talk about what everybody really wants to find out, is how to solve equations through your calculator. Real quickly, the formula is 1 over determinant of A times the switch negative C. Anyway, determinant here, let's do it. Down minus up. 4 minus 4, which I get 0. If I plug it in, I get 1 over 0 times all this stuff. 1 over 0? You can't divide by 0. This thing has no inverse. I brought this up in the last video. If the determinant equals 0, then you have no inverse. Because the very first step of finding the inverse is dividing by determinant. So if the determinant is 0, you can't divide by 0. Just keep that in mind. Determinant of A equals 0, there's no inverse. Anyway, let's go to the fun part of today. I'm going to show you how to solve equations using your calculator and matrices. This is the kind of idea. We're going to write it as I'm actually showing you two ways to solve your calculator. Let's do the proper way first. We're going to write it as a coefficient matrix. Negative 2, 1, 1, x and y. Kind of like we did Kramer's rule when I showed you real quick. 9 and 3. Then here's the idea. I'll put this in my calculator as matrix A. That's x. I'll put this in my calculator as matrix B. Now, if I want to solve for x here, which is my goal, I want to cancel out A. And the way you cancel out matrices is you multiply by the inverse. You multiply this side by A inverse. And if I do one side, I want to do it to the other side. Multiply this side. Now, keep in mind, they're both on the left side. Because matrices don't. You can't multiply AB and have it be the same thing as BA. These will cancel out. Just get the identity, which is essentially 1. That's one way to solve your calculator, is that you just rewrite this, put this in your matrix A, put this in your matrix B, cancel out the A by doing the inverse both sides, and this is all inside. Let's do it real quick. I'm going to go to my matrix. I'm going to type 2x2. I'll type that one in. It's negative 2, 1. I just typed in my coefficient matrix right there. I'm going to go back to my matrices. This time for B, I'm going to type in the little 2x1. 2 rows, 1 column. Right, and then 9 and 3. And then all I'm going to do is what I have here. Give my first matrix, multiply it inverse, and then times it by the second matrix. If I do that, press enter, I get my answer of negative 2 and 5. X equals negative 2, 5. Which my answer is a coordinate. Negative 2, unless it's a problem. Negative 2, 5. That's how you solve in your calculator. It works for 2x2, 3x3, 4x4. Always works. That's one way to solve it using a calculator. Let me show you an actually even easier way than this one, a faster way. And what's something that's called reduced row echelon form. If you ever take linear algebra, you know more about it, but this is the fastest way to solve system equations that I know. Another short for this is RREF. In linear algebra, learn all these row operations, how to add rows, subtract rows, all this cool stuff. Anyway, one of the things we can do is put into row echelon form. That is this. We're going to write this as what we call an augmented matrix. This means you write as one big old matrix. 4, 6, -2, 9, 22, and -3. I must write as one big 2 by 3 matrix. And then in my calculator, I'm going to put RREF, and I'll show you to get there right now. What that's going to do is do all these elementary row operations for us to make this part right here that identity. It's 1001 on this side, and then whatever's on this side is our answer. And that's going to be it. Let's show an example real quick. We'll actually do a few of these to make sure we got this. Now, my matrices, I'm going to type in a 2 by 3 because I'm going to put it all together. Type in everything I see. 4, -2, 22, 6, 9, and -3. There it goes with my matrices. I'm going to get out. Go back to my matrix. Now, before I select them, I'm going to go to math. There's RREF, reduce row echelon form. It has to be the double R one. Select that. Now select your matrix. And look what it's going to do. There's identity, and it says the answer is 4, -3. That's our answer. And that's the easiest way I know how to find an answer using system equations. Faster than doing it by hand, faster than, well, 2 by 2 is actually debatable. But 3 by 3, 4 by 4, that's the easiest way. Reduce row echelon form. Let's do a couple more examples, and then we'll do a 3 by 3 to finish off. Let's do application problem first. Kevin has 25 quarters and dimes. The total value of all the coins was $4. Quarters and dimes is K. With problems like these, there's only two equations. There's a value equation and a totals equation. Let's do the total one first. He has quarters and dimes. He has 25 of them. If he had quarters and dimes, he has 25 total. That's my total equation. Now let's do the value equation. Quarters are worth 25 cents. Dimes are worth 10 cents. The total value is $4. And like, solving this elimination or substitution, but there are decimals. Type it in. So I'm going to go 2 by 3. I'm going to type in 2, 4, 1, 1, 2, 5. We get out. We'll do RREF with the A and go up and select it. That's the fastest way to do it. You press enter. There you go. 1001. And I think it was 10 to 15, but let me double check. Yeah, 10 to 15. Quarters is column 1, dimes is column 2. This is quarters and dimes. See how quarters is column 1 and there's no value right here? The only value is right there. Quarters is 10. And then for dimes, there's no value on top. Dimes is down here. Dimes is 15. We have 10 quarters and 15 dimes. Application problem, write our answer in the sentence. That's how you do an application problem. That's how you solve a 2 by 2. Now, for the big finish, let's solve a 3 by 3. Actually, I'm going to go back to my notes from 37 real quick. And let's scroll down to the bottom. And let's do a 3 by 3. The easiest way to do this is reduce row echelon form. RREF of all this. The key thing to keep in mind is don't forget the negatives. If something's missing, you put a 0. If there's no Y here, you put a 0 for its placeholder. This has to be column X, column Y, and column Z. All we can do is put that in my calculator. All of it in there. Second matrix. Big 3 by 4. We type it all in. Now we get out. Go back to matrix. Go over RREF or the bottom. Select our matrix. An answer. 4, 5, 1. My answer is -4, 5, 1. You say it was all off. And that's the idea. That's the easiest way I know how to solve system equations. Anyway, that's the lesson.